Hello and welcome to this new section on risk scoring and prioritization in this course, AI for Risk Management and Compliance Excellence in the first lecture of that. So in this particular section, we will give you some good idea of how to use AI for risk scoring and prioritization. And we will begin by looking at few risk scoring models based on Bayesian networks and or supervised machine learning. So how do you think you can, use risk scoring models based on Bayesian network and supervised ML to assign dynamic risk scores to vendors, customers, or transaction based on their behaviors and attributes? Any thoughts? Right. So using risk scoring models based on Bayesian networks or supervised machine learning allows you as an organization to assign dynamic real-time risk scores to various stakeholders like vendors, customers, and even transactions. And these scores reflect evolving behaviors, right? Contextual signals and historical patterns, which enables a proactive risk management and fraud detection across industries like finance, insurance, supply chain, and e-commerce, where these incidents of proactive risk management is required a lot more. So that's a snapshot of how can you use risk scoring models. Let's take a look at why do we need to use risk scoring models before we take a look at the steps that we can take. You know, the traditional approach for risk scoring, you have static checklist. Whereas in risk scoring models, you have a dynamic score updated or adapted to the new data. So latest risk position is given. In the traditional approach, again, you do manual reviews, whereas in risk scoring models, you have a consistent, scalable, and automated scoring done. Also, in traditional approach, there is a binary outcome like is it safe or is it risky? And it is in this risk scoring model, in these risk scoring models, you have continuous scoring 0 to 1, 0 to 100, or low high kind of a range. And the another comparative analysis would be that the traditional approach has one size fits all rules, whether it's a customer versus vendor. And the risk scoring models are customized by vendor and customer type. And that makes a good sense to use risk scoring model. So let's take a look at the steps that you need to take to build and use risk scoring models. Let's take a look at that. So first you need to collect the data on entities and their activities, right? And what are the sources of this data on entities and their activities? There are, key entities that we are focusing here, and you probably need to do that also, is like vendors. And there the key data features are the country, the sector, past, service level agreement violations, financial health of the vendors, etc. Then you have another set of entities is the customers, where you need to look at, demographics, transaction history, login patterns. And then another big set of entities, the transactions itself. And there your features could be like amount, frequency, merchant, geography, and the payment method. Now, what you can add here is external data like sanctions list, adverse media, credit score, etc. And also behavioral data, velocity, device changes, network anomalies of the customers, vendors, or anyone else that you are dealing with. So like this, you need to collect data on these entities and their activities. Then you engineer risk relevant features. So out of this, you start getting what are the possible variables that could tell you about the risk of these entities. So you start engineering these risk relevant features. And what are these features? So in static attributes, you have features like country, registration type, age of the entity. In behavioral category, you have frequency of transaction, device changes. In historical category, you could look at disputes, late deliveries, SLA violations, service level agreement violations. And in contextual category, you could look at geo risk, industry risk index, time of the day. So these are some example features of the category wise, these are some example features from which you can choose one. Also, you can include risk signals like matching to, PEP or sanction list and operating in high risk jurisdictions, and also sudden deviation from usual behavior. So these are the things, these are the features that you need to, build into your model. Once you have identified the data and the features, then you need to look at your modeling approach. You need to choose the modeling approach. There are two possible options. First option is to look at supervised machine learning model if you have labeled outcome. If you can correlate the high risk situation, your risky outcome with the variables that you have. And here you could take the three-step cross approach with which you identify the target variables. Say, for example, was this transaction fraudulent on 1 to 0, binary kind of a thing. Then you look at the algorithms. You have many algorithms like XGBoost, LightGBM, logistic regression, neural nets. And then you look at the output, then you see the output, you build the output, which is the probability of risk on a 0 to 1 basis, or translate it to a risk score. So these are the three steps that you can take to use a supervised machine learning model if you have labeled outcomes. Then you need to use, as you choose the algorithms, you need to validate. You need to train the data, then you need to validate and use cross validation and AUC precision recall to evaluate. And you can define score bands like 0 to 0.4 as low risk, 0.00 to 0.4 as low risk, 0.4 to 0.7 as medium risk, and 0.71 to 1 as high risk. And this could be based on the industry. So this is just treat this as an illustration. The second option you can choose in modeling is the Bayesian network model. And if you want explainability and interdependence in your modeling. Now, Bayesian networks are, first probabilistic model, not deterministic. And they are graphical models that can show causal relationship between the variables. And the benefits of using this approach is that it's transparent, has a transparent reasoning, how A affects B. Works well with missing data. It's good for compliance and auditability because you have traceability, you have explainability because of the causal effects. And the tools that you can use are like PGMPY in Python, BMLearn in R, Huggin, Bayesian Lab, like which in the GUI-based commercial tools. And an example of, let's take a look at an example of a vendor risk scoring in which you can look at location risk linked to a vendor risk score, or you can look at financial stability as a parameter leaving to related to the previous disputes. So like this, you can look at the vendor risk scoring. You need to use prior life probabilities and evidence updating to calculate the final scores because the history will definitely determine what is the risk score and the risk actual in future. Then you need to score new inputs dynamically. Once you have chosen the model and built your model, trained and validated, you need to deploy your model via API or as a part of a scoring pipeline. And there you look at, for a new vendor onboarding, you can look at the risk code before approval. For real-time transaction, you could look at risk code before processing. For customer behavior drift, you could look at auto update the risk profile and integrate these scores into, things like customer, ERP, customer systems, ERP systems, transaction processing systems like banking and fintech, and alerting systems. So you need to then link these, your risk scoring models, into your workflows and systems. Then once you have done that, you're ready to get triggers and triggers for action based on the risk scores. Now, if your risk band is low risk, right, then your automated actions could be auto approved. If your risk band is medium risk, you could require manual review or additional documentation. And if it is high risk, obviously you could do blocking, flagging, or escalate to a compliance or a fraud team. So like this, you can trigger action based on the risk score. And what you need to do is to score, your score thresholds can be dynamic. You know, they need not be a fixed band like 0 to 0.4 defined for low risk. It could be dynamic, could be adjusted based on the business rules, real-time trends, or feedback loops. If you find that 0 to 0.4, the risk itself is creating risky situations, then you might even lower that band to 0.03, less than 0.4, right? So like this, you can trigger actions based on the risk score. Then you need to keep monitoring, explaining, and improving the model. There are a couple of things you need to do. Track the model drift, which is the changes in accuracy of your model over a period of time. Analyze feature importance, which feature is more important using SHAP value, and tune thresholds based on the false positive or negatives. So you keep looking at the results and keep defining your thresholds accordingly and use the feedback which will result from your investigation of the outcomes to retrain your model. So like this, you monitor, explain and improve your model. Let's take a look at a real world use case in fintech transaction risk scoring. So here, the historical fraud rate has been 2.4%. The top features that this company used was device ID, IP, transaction timing, and they use XGBoost and SHAP explainability as a model. And their output was a real-time risk score of on scale of 0 to 100. And the result, what they got was they were able to get their frauds down by 35% and review the workload cut by 40%. So that's a good example of a fintech transaction risk scoring being used for reducing the fraudulent activities. What are the tools and tech stack you can use? So there are many, and for each layer, you need to go by a layer. For data pipeline, you can use Airflow, dbt, Kafka, Snowflake, BigQuery. For machine learning model, you can use scikit-learn, XGBoost, LightGBM, and TensorFlow. For Bayesian modeling, you can use PGMPY in Python, BNLearn in R, or Bayesian Lab. For serving and API, you could use MLflow, Fast API plus AWS SageMaker. And for visualization, the very familiar Power BI, Grafana, and SHAP dashboard. So that's a look at the tools and tech stack that you can draw from. What are the business benefits of using this risk scoring models? First, you get real-time risk visibility, which can help you make dynamic decisions at onboarding or at the transaction time. Also, there is reduced fraud and non-compliance, by which you can catch risky entities earlier, the entities itself. Then it is scalable and explainable decision making, in which can support regulators, auditors, and stakeholders. And there is a continuous improvement possible with feedback loops enabling smarter scoring. So these are a couple of few business benefits that you can think of. So what do we do next? So we will look at another part of risk scoring prioritization in the next lecture, and we will take a look at how can we use reinforcement learning to update the risk scores based on the new data or feedback. So thank you so much for watching this first risk scoring and prioritization lecture in this course. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.